Good morning, good afternoon, everyone, depends on where you are. Welcome to today's MSC Apex Feature Pack 2 release webinar. In today's webinar, we'll introduce you the latest functionality of MSC Apex. My name is Zhang Lang. I'm the Product Marketing Manager of MSC Apex. Today, I'm pleased to have Larry Pierce, our Senior Lead Application Engineer, to give this presentation. Larry got his master from Orphan University and has more than 20 years experience in FBA. He's now the Senior Lead Application Engineer of MSC Apex at MSC Software. So let me give you Larry Pierce. Larry, please give the ball.
Great. Can you hear me fine?
Yeah, I can hear you.
Fantastic. So my name is Larry Pierce, and I am excited to be here today to share the new capabilities that are in the Iberian Lynx Feature Pack 2 release of MSC Apex. And in this release, there is a lot to be excited about, especially when it comes to reuse of an existing Orphan mesh. We're going to see that Feature Pack 2 has capabilities that easily allow us to not only reuse, but also repurpose or re-engineer or even reverse engineer a new finite element model or geometry model from an existing Orphan mesh. But before we dive into what's new in Feature Pack 2, I just want to quickly recap or remind you of what was new in Iberian Lynx and the Iberian Lynx Feature Pack 1 release. Okay? So the primary focus of the Iberian Lynx release was interoperability between MSC Apex and Nastran. This focused on three key areas of interoperability. The first was support of Nastran entities, parameters, and options, and collectively we kind of call this keyword support. And the focus here was to support not just in the textbook sense, but in an innovative Apex sense, where we were enabling direct interaction and automatic model update of items such as coordinate frames, rigid body elements, all those Nastran entities that you know and love. Another interoperability focus of Iberian Lynx was the reuse and repurposing of a model that started as an Orphan mesh. Now, Iberian Lynx only supported repurposing an Orphan shell mesh into a shell geometry. We're going to see that this capability has been greatly extended in Feature Pack 2. Matter of fact, that's something you should really be excited about, and we're going to learn more about that in just a couple of slides. Lastly, Iberian Lynx included support for post-processing Nastran solution. This makes the interoperability between Apex and Nastran a complete round trip. It also enables Nastran users access to the innovative and interactive post-processing capabilities in Apex, such as Apex Mesh Independent Cross-Section Sensor. If you've ever used a Nastran monitor point, for instance, to determine shear and bending moment at a section cut in your model, the cross-section sensor in Apex is a mesh-independent version of that. You should be very excited about that. Additionally, Iberian Lynx, in addition to having a lot of stuff related to Nastran and Apex interoperability, it also added a lot of additional enhancements in geometry, meshing, both hex meshing and surface meshing, some enhancements in post-processing. And one of the areas that I'm particularly excited about was some enhancements in scripting, including support for user interface and picking support in a scripting environment. If you want to learn more about Iberian Lynx, you can check out our webinar from earlier this year, or just give anybody at MSC a call. We'll be glad to share with you. Okay? Now, Feature Pack 1 had a lot of tools in it, a lot of tools and functionalities, especially scripting actually, to enable automated conceptual modeling from minimal CAD geometry. And oftentimes the CAD geometry we're talking about is like datum planes, datum curves, maybe outer mode line surfaces, not the feature-rich, solid geometry that has all the fillets. We're talking the bare minimum here. Key elements to supporting conceptual design in Apex, honestly, starts with Apex, the innovative environment that is Apex. That's what has drawn many of our customers to use Apex for conceptual modeling. It's just Apex itself, but we added a lot of stuff that people were asking for that would really make their conceptual modeling process that much easier. Things such as mesh control curves, stiffened panel modeling, and then a lot of little tweaks to the API just to kind of round that out and turn that into a truly exciting thing. And we have a lot of customers that are using Apex for conceptual modeling right now. So that brings us to Feature Pack 2, all right? Now, the primary focus of Feature Pack 2 is once again on Apex Nastran Interoperability, all right? We're going to see some major extensions to the mesh as geometry. Another way to say that would be Orphan mesh support. This was, of course, initially introduced, as I just shared, in Iberian Lynx, and we've greatly enhanced that in Feature Pack 2, and that's why we're coming out with Feature Pack 2. We just don't want to hold this. We want to get it to you as quickly as possible, all right? Next, we'll see some additional support for more Nastran keywords. Once again, we're talking, supporting entities and parameters and options, sort of collectively we call that keywords. The third area of Apex Nastran Interoperability is post-processing. There's nothing in Feature Pack 2 that's new in that area, but you can expect a lot of new stuff coming in that in the next couple of releases at the end of the year and early next year. So let's dive into this concept of mesh as geometry, starting your process in Apex not from the CAD geometry, but starting from an Orphan mesh, okay? So we're going to see that these capabilities allow us to remesh. Now, remeshing is the easy part, to be quite honest with you, but they're also going to allow us to reuse and repurpose. That's actually pretty exciting, okay, because I'm going to be able to take a model that I may have used for one analysis, and maybe I need to make some changes to it and then repurpose it for another analysis. And even more exciting than that is that the way we're doing this in Apex is going to allow you to, quite honestly, redesign and re-engineer from an existing finite element mesh, okay? Now, there are many reasons to start a modeling behavior or to start a modeling endeavor from an Orphan mesh. Sometimes it's because the geometry just doesn't exist or is lost, right? Sometimes it's because you've not used a cool tool like Apex that keeps all that stuff in sync for you, right? Other times it's because from a subcontractor or a supplier, all you received was the mesh, right? So that's kind of what you got to start with. You didn't get the geometry. And sometimes it's because you want to leverage the investment. It costs money to make a finite element model, right? So you want to leverage the investment, the time and the money that you put into this existing mesh, partly because that mesh represents the behavior of your structure. Your structure is physical. Your finite element model is an abstraction of that, right? But you've created an abstraction that accurately reflects the behavior. You've used it for margins of safety. You've correlated it to tests. You've written certification documents based on it. So you feel that if I start the next phase from this existing mesh, I'm having a more of an apples-to-apples comparison, right? Because I'm actually starting from the behavioral representation rather than the physical representation. Last thing on this slide, I know this slide's not very exciting, but I want to kind of just dive in just a minute to the terminology mesh as geometry. When we read in an Orphan mesh into Apex, we're actually going to turn that into geometry, and that's exciting because that allows us to easily preserve loads boundary conditions, attributions such as thickness and material assignment, and it's also going to enable many of the tools that you love in Apex, the direct modeling, to be used on this, as well as automatic model updates or the generative nature of Apex as well. So once again, to reiterate, mesh as geometry is a way of supporting many common workflows that begin with an Orphan mesh, and it's going to allow you to, my theme for today is to remesh, reuse, repurpose, redesign, and re-engineer from an existing mesh. Key capability is because of the methodology that we're using in Apex, you're going to retain loads, boundary conditions, and attribution of the model. You're not going to lose that. So this effectively allows you to create design changes that start with an Orphan mesh. And honestly, use your imagination because there's a lot of things that you can do that I probably haven't even thought about yet. An example is on this slide where we start with a mesh that's in a file, right? Nastran terminology would be a bulk data file. We import that into Apex. We turn that into facet geometry. And then from that geometry, we're able to do some exciting things, such as perhaps add an additional flange that wasn't there. So we're kind of re-engineering now. We're kind of redesigning now. Maybe even adding a cutout that was not part of the additional mesh. Once again, remeshing is the easy part, and of course we can do that as well. We're going to do this example live, so you'll get to see all this live, and you'll get to see it live. Now, Iberian Lynx only supported the creation of or only worked with an orphan mesh in the sense of working with shell meshes. We would turn the shell mesh into a surface geometry representation. Iberian Lynx was the first release where we did this, and so a lot of our geometry tools that you wanted to use was a very limited subset of those. And in Iberian Lynx Feature Pack 2, we've added many more of the native geometry operations now work on the geometry that's created from the shell mesh that you import. Things like splitting, which is an excellent thing to do if you want to remesh locally in an area. Booleans for adding and subtracting, adding, removing vertices, transform, and actually there's a few other items on the list as well. So all that is new in Feature Pack 2, so it really extends and really builds on what was there in Iberian Lynx. Another big thing in Feature Pack 2 is not only do we create the facet geometry for shell meshes, we also do it now for solid meshes too, right? So I can import, for instance, a TET mesh. I can turn that into a solid, and then I can remesh it. I can actually, we're going to do in the demonstration, we're actually going to add an additional gusset to a model. So we're going to stiffen a model, and we're going to do all of this starting from a finite element mesh. My tongue gets tangled sometimes. So let's dive into a demonstration because that'll be more fun than my words. All right. So we're in Apex, and we are going to do two things with orphan meshes today. The first, we're going to import a solid because that's new and exciting in Iberian Lynx Feature Pack 2. And then we'll also do something on a surface or shell mesh as well. So we're going to import the bracket that you saw in the presentation. Okay. So Apex is previewing what's being imported so you can kind of check and make sure that your units are correct and various things like that. So here's the bracket. And this is a bracket that might be used in a dynamic analysis. Maybe it's actually being used to support some structure, which is in this case, I'm just representing that structure as a concentrated mass. I'm just connecting it to my mesh. And I've also got some constraints there as well. All right. So we can see the constraints. And I could, if I wanted to, I can do a lot of different things with this. Perhaps this model existed in Apex before. Maybe I actually want to do an analysis with it, so I could just import it and export it if I wanted to. So we'll just do that real quick just to create a finite element model that may have come from this. All right. I can also, once I've done that, and maybe I have run the model with Nastran, I can, of course, post-process this. So even though this wasn't built in Apex, this was just a bulk data file that I imported. I'll just import some Nastran results that I have already run. Okay. So let's look at those results real quick because they're going to form the basis of the changes that we want to make. So I'm looking at some results from a normal mode analysis, and I see that my first frequency is at 12.9 hertz. And maybe that's too low. Maybe I need that frequency to be a little bit higher, okay? So what I really want to do here is I kind of want to redesign this part. I want to stiffen it up a little bit. Maybe I can't create a new part. Maybe I need to somehow work with this part. And I might actually be able to increase the frequency and stiffen it up if I just add an additional gusset there, okay? And as I indicated earlier, maybe this came from a supplier. Maybe this is all I have. Maybe I don't have geometry. Of course, this is not the most complicated structure in the world. I could probably, create some geometry. I could create some geometry really quickly. But we're going to start and kind of illustrate the workflow of starting from an orphan mesh, all right? So the first step in that is to actually create our solid. That's going to, since the solid is derived from the finite elements, we call this a facet body. So it's a special kind of body in Apex. Apex has a special tool to create this where it's, of course, identifying all the feature edges and angles. I can totally modify this if I want to. I'm going to accept what Apex has decided on, all right? So now Apex has created this faceted solid. As a matter of fact, I can now actually get rid of the mesh. I don't need it anymore, all right? So now we're just working with a solid. I'm going to turn on some edge colors here so it kind of looks like Apex solids always look with the green edges for the feature edges and such. And now what I want to do is I want to add an additional gusset. And the way that I'm going to do that in this example is I'm really just going to copy one of the gussets that are here. And so in order to do that, I'm going to need to split this up into, I'm going to need to separate or split off one of the gussets so that I can actually copy it. So we're just going to make some splits on this. We're going to split it into multiple solids. Notice that while I do this, I'm retaining my loads and boundary conditions. I'm not losing that. I'm retaining my material properties. I'm not losing that. But I am splitting this now into multiple solids. So I've actually separated out a gusset now. So I want to come in and transform this to the middle. So I'm going to make a copy of this. So I want to keep that. I know, for instance, this is 12 inches across. So I'm just going to transform it so that it'll be in the middle. So I'll do a little math here. So I've created a copy of a gusset, and that gusset originated as a tap mesh. All right. So I still have multiple solids here. So let's actually Boolean those together. Another operation available with the faceted geometry in Apex. So now we're back to a single solid. And if it was my goal to do a tap mesh on this, I would effectively be done. I'll tap mesh it, I'll run it, and I'll compare my results, and I'll see if what I thought was true, which I know it's true. I know this is going to stiffen it. I know this will raise the frequency. But just for fun, I'm going to hex mesh it, okay? Because it's not the most complicated geometry, and I think I can hex mesh it very quickly in Apex. Apex is, you know, there are many areas where Apex has really, really garnered a lot of users, and one of those is, of course, mid-surfacing, and another one is in the hex meshing arena. Because in Apex, it's very easy to turn this into something that is hex meshable. We do that by first turning on the meshability colors. Red, of course, means that I cannot hex mesh it, right? But green means that I can hex mesh it. So a little bit of art, a little bit of science here, not too difficult. I'm just splitting this up until everything turns green. Apex creates a hex mesh by sweeping things. So as soon as I get all of these areas that are sweepable so that the mesh will be congruent, I'll be done. And so I've just been splitting it at some planes until everything turns green. Now that everything is green, I know that everything here is hex meshable. I've been using the term split. Maybe partition would be a better term. I've just been partitioning it. And of course, you can see the dotted white lines that represent the split between the partitions. Now I'm going to do the hex meshing part. Just going to mesh it with 1/2 inch on the mesh size. So we'll get a mesh very quickly there. All right, so we got a hex mesh. And now I'm ready to do an analysis. So let's actually do a quick analysis so we can confirm that my redesign actually worked. So in Apex, we do that by adding it to the analysis scene. And the analysis scene is basically where we get the model ready for analysis. So I will now export this out for analysis. And let me actually export it and put it in a location where I'll know where it's at. So I've got a folder here, and let's give it a name so that I'll know what it is. I'll just use my name. All right. And actually, I don't want to use my name. I want to just do test. All right, there we go. So we'll export this. Once it's exported, I'm just going to run it real quick with Nastran. One of the advantages of hex meshing here is it is going to run just a little bit faster than if I had tap meshed it. We're just doing a quick normal modes analysis with Nastran just to make sure, just to confirm that my redesign worked as I would expect it to work. So we'll import those Nastran results. There they are. And now we'll just look very quickly. And we can see that the first frequency is now 15.1 hertz. So I absolutely increased the frequency as I wanted to. And I can even go back and compare. So Apex has actually sort of kept a copy of the tap mesh behind the scenes so that I can actually just confirm, yeah, it was 12.9. You know, I did remember that correctly. And my change did increase the stiffness, which of course raised up the frequency. All right. Let's look at another example of using an orphan mesh to create something that we can redesign and repurpose. Here I've actually got a small section of an aircraft wing, and we'll let this represent the global finite element model, right? Just a global coarse grid representation of the wing. And you can see there's a piece that's missing, and that's a submodel or a local model that includes the rib in that section. And perhaps I've actually used that already on some analysis, and I want to actually import that into Apex, and I want to reuse that for a subsequent analysis. So let's do that. So we're going to import another finite element model, and this finite element model is going to be of that subset or that local region, and we'll import that into Apex. And there it is, so I can see it now. So I've got a finite element representation that's the global representation of the wing, and I've also got a finite element representation that is the local part. Let me actually move this up into my assembly here, and let me just show this part only, all right? And let me shade it so it'll show up a little bit better, all right? So this is now just finite elements, all right? I want to turn that into something that I can reuse and repurpose, right? Maybe my goal is to maybe do a buckling analysis or a modal analysis or something, and I need a more refined mesh. And as we're going to see in this example, I'm also going to introduce some design changes that have occurred from when I created this model the first time. So let's start out by creating those faceted surfaces. So I'll pick everything, and I'll just let Apex, do its own thing there. I could change what those surfaces looked like in terms of surface edges and boundaries, but we're just going to go with what Apex picked because this geometry is not too complicated. Let's auto color everything, and let's make the mesh wireframe so it'll show up a little bit better when we look at what we're looking at. Great. So the first thing I want to do is, once again, there's been a design change, and there's actually been a flange that has been added that was not part of the original geometry. And I'm going to add a filler surface here. So I'll simply come in and I will select some vertices here to actually define the edges or the corners of my surface. So I'll pick those. And there is my surface. Notice my surface shows up in the model browser. It's a different color because at this point it's actually a separate surface. It's not even connected to the surface that was created from the finite elements. I'll just do an edge and vertex drag on that to make sure that it intersects with the underlying faceted surface. And now we'll do a Boolean operation to just connect it in. So I'm going to tie in the new surface with the surface that was created from the mesh. So I'm now seeing that it is tied in. I can see that it doesn't have a mesh on it. If I hide the mesh real quickly, I can absolutely confirm that it's tied in by looking at the edge colors in Apex. So the red edge would be a free edge, but a yellow or green means I'm actually stitched together. So I know that this new surface that I have added is now added to the rib. Let's go in and let's create a finite element mesh that includes that. And I'm going to refine the mesh a little bit. I'm going to use a 1/2 inch mesh size. And we're just going to remesh this whole bottom section here. Okay? So we got the rib, we got the stringers, and we got the skin. And the mesh in this particular area is not exactly the mesh I was hoping for. So let's actually tell Apex to lean more towards map meshing this. So we'll just simply pick everything again. And Apex has put a really nice map mesh in there for me. And I did that by telling Apex to lean more to that as opposed to leaning more towards a paver mesh, which is what the automatic was doing in that particular case. All right. So I've created a new model that's got a new rib. One of the things that I might want to do at this point is just to validate that all my properties and my attributes, that they've been maintained on this model, right? So I can do that in Apex quickly with the model browser. I can make sure that materials are there. I can make sure that sections are there as well. It'll highlight things as I pass over it. In this particular case, though, I'm actually going to turn on the shell thickness. And the reason I'm doing this is I can see that everything that I imported has a thickness. But what I created new doesn't have a thickness yet because it's new, right? It wasn't part of the original stuff that I imported. So let's actually put a thickness on that, and I want the thickness to be the same thickness as everything else that's in the rib. That's easy to do in Apex by going to the section view. When I go to the section view, I can select the thickness that's assigned to the rib, and I can actually assign that thickness very, very quickly to my flange, which was, of course, new. And I will validate very quickly by turning on the 3D thickness again, and I can totally see that, okay, I do have a thickness there. So once again, I am started from an orphan mesh, and I am creating something new effectively, reusing, repurposing, redesigning, re-engineering at this point. The last thing I want to do is I actually do want to add a cutout because there's been a design change and there's a hole there now, some kind of access hole perhaps. So we will simply use the tools in Apex. We'll use the Boolean tool again, and this time we'll do a subtraction. So we will subtract from that, and I see that I forgot to delete this, so we'll delete that. There we go. So I will subtract this solid, which represents the hole, from the original surfaces there. And I can see that I now have a hole. I can once again confirm that I've not changed any of the attribution. Any loads, boundary condition, thicknesses are all still there. I've not lost any of that. Of course, I'm even working with a mesh that's different than the original mesh that was there. The last thing I want to do here is I want to add fasteners. Maybe were fasteners that were there originally, but maybe I have a new fastener pattern now that I've got a redesign. I've got a new fastener pattern, and I could define that fastener pattern in many, many ways, okay? Maybe some people I see that define a fastener pattern. Sometimes they use curves to represent the fastener locations. Sometimes they use points to represent the fastener locations. That's what I'm doing in this case. In this case, I'm actually going to do point-to-point connections. So let's actually use mesh seeding in Apex to define node locations where my fastener locations are. So I will simply come in here and I will select all my points, and I will select all the surfaces that I want those points associated with. You can see that Apex has now put a node where all of those points are located. These are called seed points in Apex. I've also got a cover plate here for my access panel. And the next thing that I would need to do is to actually, connect the points to create the fasteners. It's really easy to do. We have a nice connector tool in Apex that does that. Allows you to click, 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 click. But in this case, I've got a lot of fasteners. I really don't want to click, 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 click. So I will use a script, and this script will allow me to actually create them all at one time. So this is actually creating bushings. The bushing properties could be derived from the thicknesses and the material properties from the things that are being connected, as well as, of course, the material for the stiffener, for the fastener. And I created 52 connectors in just a few seconds here. All right. So the point was I imported an orphan mesh, and I actually turned it into geometry, surface geometry in this case. And I actually made quite a few modifications to this using the geometry tools that are in Apex, remeshed it, totally repurposed it, totally redesigned it. Started with an existing mesh that represented behavior, modified that, and I now feel I have a more apples-to-apples comparison with the previous design because I've inherited the behavior that was part of the orphan mesh. All right, let's look at some other new things that are in the Feature Pack 2 release of Apex. We have support for more keywords, and when we talk about keyword support, we're talking about Nastran entities, we're talking about parameters, we're talking about options. And in Feature Pack 2, we added more support for masses. Of course, masses are important for dynamic analysis, and of course, anything with gravity in the solution as well. We always supported the point masses, which in Nastran terminology would be the CON-M2. In Feature Pack 2, we added support for the CON-M1, which is a mass matrix. You directly enter the mass matrix. We also added support for non-structural mass. Non-structural mass is often used to represent like the weight of paint, the weight of maybe acoustic linings, the weight of carpeting, and of course all these things, their weight, although they're not structural, in other words, they're not carrying the load, they do affect the dynamic characteristics of the model. So oftentimes you do want to include those in your analysis. We also added support for the weight to mass conversion in Nastran, the weight mass. I know a lot of people like to work with density that's in weight units instead of mass units. Of course, mass units are required by Nastran to make sure we have a consistent set of units for the solution. Apex has always guaranteed consistent units, but in order to allow people to keep using weight mass, if they want to use weight mass in the bulk data file, we've also now added support for weight mass. Added support for the R joint in Nastran. We added support for joints in Iberian Lynx. We did that with an RBE2, and we selected specific degrees of freedom. We've now extended that to support the Nastran R joint. And we also added some additional ID management capabilities. You can now label and find loads of boundary conditions based on their set IDs. And we also added more renumbering control for nodes, elements, and coordinate frames. In Iberian Lynx, you could renumber parts and assemblies. Now you can renumber individually selected elements, nodes, and coordinate frames. I want to do just a quick demonstration, very short demonstration on the non-structural mass, okay? So let's do that very quickly. Here I have a muffler and I have a floor panel, okay, that the muffler is attached to. You may recognize this model. This was a model that in earlier releases of Apex, we used this to illustrate some of the exciting post-processing capabilities we have for frequency response analysis, okay? In this particular example, I want to use this just to illustrate the non-structural mass capabilities that are in Apex. So in terms of attribution, as I said, for point masses, we now not only have support for the ConM2, we also can now enter in the mass matrix, which would once again correspond to a ConM1 for Nastran terminology. And we also have added non-structural mass support. For non-structural mass, you can enter the total, or you can enter per area or per length. Per length is kind of exciting because I can imagine that you might have cabling, and the cabling, of course, is not contributing to the structure, you know, it's not carrying load, but it might affect the dynamic response of the structure. So now you can effectively use non-structural mass per unit length to represent the mass of perhaps some cabling that might be in your structure, all right? So let's just do a non-structural mass per area, all right? And we'll just simply select that surface, and you can see that Apex has put this non-structural mass all over this surface. Perhaps this represents an acoustic lining material. Maybe it represents the carpeting that's assigned here. And what I'm going to do real quick is I'm just going to quickly check to see what the non-structural mass is for this part. I entered in 1 per unit area, and of course I didn't actually check what the area was, but we'll just do a quick little, I got a quick utility I wrote that'll quickly tell me what the non-structural mass is that's been assigned to this floor panel. And it's showing me that it's about 847, all right? So I'll just accept that value and I'll close that out. The neat thing about this is, like everything else in Apex, this is generative. So if I come in and I change the size of the floor panel, the non-structural mass is going to update automatically. It was 847, all right, for the original structure. And if we come in and we check it now, what we will find is that it has, of course, increased because I increased the size of the surface. So once again, we've added support for a Nastran keyword, but we didn't just add support, what I call textbook support, right? We went above and beyond. We're putting this in Apex, and Apex has this innovative direct modeling environment, this great capability which we call generative, which is automatic model updates. So now changes that I make to the model can be reflected in the non-structural mass, which is just a Nastran keyword, right? But now it's a Nastran keyword on steroids because it's in Apex. So there's a few miscellaneous things that were added in the feature pack 2. So we've already talked about a lot of exciting stuff. Just to kind of cross the T and dot the I and finish everything out. Some miscellaneous improvements. We now have the ability to import only parts that have changed. So you can imagine importing an assembly that might have 1,000 parts, and somebody says, well, some parts have changed, rather than you having to go and just re-import that particular part that changed, Apex will now figure this out for you. So you can import the assembly again, and Apex will optionally only import those parts that are new or modified. And on import, you need to select this toggle to skip unchanged part assembly, right? We also have added a preview, so now if somebody sends you this big assembly with all these parts, rather than you just reading it in and you finding there's a lot of stuff there you don't want, you can actually preview this before you import and select just the parts or the assemblies that you would like to import. And then lastly, we've made some additions or extensions to our unit systems. Previously, the angle that was represented in our unit systems was actually doing two things for us. One is it was used for angular velocity and angular rotation, which from a consistent solver sense needed to be radians, okay? Because most solvers always deal with those things in radians. Even rotations at grids is usually reported as radians. But we used angle not only for the solver sense of things, but also for user interface facing things such as transformation rotation angles, material angles, or feature angles. And so if you selected a consistent set of units in Apex, that meant you were using radians, which kind of meant that if I'm doing a material angle, defining that in radians is not that fun, although Apex would convert on the fly. You could type in 90 degrees and it would convert that for you. To make that even simpler, we've separated rotations from angles. So now angular velocity, angular acceleration use a new entry we call rotations, which will be in radians, which gives us consistent solver units. And we now have angle, which is more for the user-facing definitions of angles, such as rotations and material angles and such. Okay? So I hope you've enjoyed today's presentation. I hope you got a lot from it. I hope you see that Apex and Nastran interoperability continues to grow at a rapid rate as we address Orphan mesh support for surfaces and solids now, as we address keyword support, in other words, entities, parameters, and options, that continues to grow. And you'll see more in the post-processing arena, although you saw it live today. It's actually pretty cool. Well, you'll see more of that in future releases. Well, thank you for your time, and I'm done, Zan Lang, and let's see if anybody has some questions.
Okay, thank you, Larry. Everyone, if you have any questions, please raise it up in the Q&A session in the red part of your screen. And if you don't have any questions, well, we'll pick it other people's questions. Please help us to fill in the polling session in the red part of your screen as well, so that we can follow up and provide you the video recordings or demos or whatever you need. So I do have one quick question here, Larry. Billy asked, what happens if there is a larger, more complex existing recreate? Sorry, I have to read the question for you. Sorry. Okay, what happens if there is a larger, more complex existing mesh? Do you always have to delete the full mesh and recreate? Or is there a way to remesh only an area of that interest?
Oh, that's a really good question, actually. Yes, you can remesh individual faces of the surfaces that have been created. In my example, I just chose to kind of remesh a lot of stuff, but I could have remeshed an individual face. So that's a really good question. Thank you very much for that question. So you do have local control.
Yep. Do we have any more questions? Let's see. Well, while we're picking up the questions, probably I have one for you, Larry. So, like, for example, what do you think about the enhancement and potential application of this new functionality we added into this feature pack 2, especially the enhancement from Orphan mesh from 2D application, from the shell element into a solid element? So what's your comments for that new functionality?
So this is actually really exciting. Apex has always been able to import a Nastran bulk data file. We could move nodes around, we could change properties and add loads and boundary conditions. But with the meshes geometry capability that we have now, it opens up so many workflows for people. One, to remesh, okay? And as illustrated in my two examples today, I can redesign, re-engineer, and totally repurpose things very easily. You know, it could be as simple as I want to remesh a local area where there was a high stress gradient, and I just want to see if a finer mesh improves that result. I absolutely can do that by splitting surfaces or splitting solids and then introducing local mesh control in those areas. So there's a lot of exciting possibilities, including in future releases, taking the geometry out of Apex and actually sending it back to the CAD system. So a lot of exciting possibilities are existing today in Feature Pack 2. There's a lot you can do today, and we're also set up very well for a very exciting future too.
Okay, I think I have more questions. So Tarek raised the question, can you attach different sizes of mesh or connect two different sizes of mesh?
And so the answer there would be yes. I can connect multiple sizes of meshes, and I can do that in multiple ways. I mean, it's possible that I've got two meshes that are completely separate. I could connect them with fasteners. I could connect them with Nastran glue. I could Boolean stuff together and then remesh, and I'll get a congruent mesh after the Boolean operation on the geometry. I also could tie things together with RBE2s or 3s. So there's a lot of possibilities there. So the answer is yes, I can do that in many ways, just depending upon which way you want to achieve that.
Okay. Another question following the first round question. So the customer said, we mesh many in hex elements. So do you see a future in developing this capability within Apex?
So read the question one more time.
Sure. We mesh mainly in hex elements. Do you see a future in developing this capability within Apex?
Absolutely, and actually the future is now. I mean, Apex is already excellent at hex meshing, and there are many reasons that people are drawn to Apex. Sometimes it's just the user environment, which is really modern. The other reason is we're excellent at mid-surface meshing. Of course, we're excellent just in CAD to mesh in general because of the direct model interaction. And another area that I see a lot of interest in Apex today is hex meshing. I get a lot of people who see hex meshing in Apex and they then want to do hex meshing in Apex because it's so easy to create these meshable regions or partitions in the geometry. And if you're interested, I'll be happy to, contact you. We'll look at your problems together. I've hex meshed many very difficult parts for people. So I think the future is now on that. So. Okay.
Another question is, can I import a solid and a shell mesh model and generate the Orphan mesh CAD? So is it one step or two solid then? Oh, is it one step or two? Solid then shell?
That's a good question. So if I have a finite element model that has both shells and solid, it's really going to be one step. Okay, I import that model and then Apex is smart enough to figure out that, the shell elements will be a surface and the solid elements will be a solid. So that's one step, yes. Okay. If you wanted to make it two steps, you could, but it's really one step.
Okay. Yeah, I think that's all the questions we have right now. Okay, we have more. Okay. Another one is, okay, I noticed in your customer two palette, you have create point interpolate. Does this behave like patterns create point interpolate? And what could someone interested in this feature download it? where could someone interested in this feature to download it?
Oh, yeah. So contact me directly, and I'll send it to you. I wrote it. So I've, of course, have been at MSC forever. Of course, I'm very, I know a lot about Patran. And that was a particular function in Patran that I kind of missed in Apex. Although Apex has got some other really neat capabilities, I kind of missed that. So I just wrote a utility for it. So, yeah. So if you contact me directly, larry.pierce@mscsoftware.com, I'll send it to you.
Okay. And another question is Apex able to manage or create pyramidal elements?
Pyramid elements.
Yeah, pyramidal. Yes, sorry.
So that's a really good question. And the answer is not today, not in Feature Pack 2. Of course, Nastran has pyramid elements now, and they will be in Apex. I don't know if they're going to be there at the end of this year, but I fully expect them next year. And one of our goals is to be able to, a lot of times for hex meshing, there's just some regions that are really tough to hex mesh, right? So there's many uses for pyramid elements, one of which would be to, connect a hex element to a TET element. So you'll see a lot of things in that area, but we don't do it today, but we will do it very soon.
Okay. Another question, can you toggle the background to white yet without the use of a bitmap? I think I can answer this question for you, Philip.
Good.
So currently the background color of Apex is dark and blue, and this out of the design papers for long-time user every day. But we do have a proposal to bring a light theme background color and icon colors. But that will not be in this release. It will be available in next year's release. So we will have 2 themes available, and you can toggle between the dark blue theme to the light blue, less bright color theme. So there will be 2 themes available in next year's release.
But it's also true, Zanlang, that I can change the background color today. So there is an icon that will let me do it. So you're talking about a more global change, but I can make a quick change if I want to make a bitmap image to put in a report. So, yeah.
Yeah. But for the presentation purpose, maybe the white background color is not very compatible to our black theme, right, of the icons. But next year we'll have a better appearance and for both the background color, also the icon flat.
Exactly. No, you're correct. Thank you.
Yeah, thank you. Another question is do you have CGAP elements in Apex?
I'm sorry, I don't. CGAP.
Yeah.
Oh, CGAP elements, Nastran CGAP elements. So
okay.
The answer is no. Apex does not generate CGAP elements at this time. So if you needed CGAP elements, we could create bars, and then those could be converted into CGAPs outside of Apex, but Apex does not support them yet. So.
Okay. And if you have more questions, please raise it up right now. And if you don't have, please help us to fill the polling session so that we can follow up, and maybe Larry can send the script if you are interested. I think that's all the questions I have received now. Okay, let's see whether there will be more questions. Any more questions? Let's see again. Okay. Yeah, I don't see any more questions coming up. So I guess probably this webinar. And thank you, Larry, for the presentation and the Q&A. This is really a good webinar. So please share me the document so that I can share to our users, and especially for those who didn't attend.
Exactly. And once again, if you have questions and you didn't get a chance or you didn't think of it right now, feel free to email myself or Zanlang or any other MSC representative, and we'll be happy to answer your questions. So,
yeah, for sure.
All right. Hey, well, thank everybody for their time today, and thank you, Zenlai.
Yeah, thank you, Larry. Thank you, everyone, for coming to attend our webinar. So that's today's webinar. We'll talk to you soon. Thank you.